For the first time in human history, scientists have a real photograph of a planet that isn't ours. Not a computer simulation, not an artist's impression drawn from guesswork. An actual image, captured directly, of a world orbiting a star that isn't our sun. And here's the part that's making astronomers lose sleep tonight. This planet shouldn't even be sitting where it is. Stay with me until the end, because after this first jaw-dropping image, James Webb went on to find something even stranger. A planet that might already be hiding the strongest hint of alien life we've ever detected. But before we get there, hit subscribe right now, because what you're about to hear tonight genuinely changes the way we think about our place in this universe. For decades, capturing a direct photo of a planet outside our solar system was considered one of the single hardest challenges in all of astronomy. Not difficult, not tricky, nearly impossible. And the reason comes down to simple physics. A star is billions of times brighter than any planet orbiting it. Trying to photograph that planet is like trying to spot a lit match standing right next to a lighthouse. Except you're trying to do it from another city, through fog, at night. Every telescope before Webb struggled with this exact problem. The starlight simply drowned out everything else. Scientists dreamed about solving this for years, but the technology to actually pull it off didn't exist yet. Then came James Webb. Its enormous mirror, combined with specialized instruments built specifically to block out overwhelming starlight, finally made this decades-old dream something scientists could actually attempt in real life, rather than just theorize about on paper. And what's remarkable is that Webb didn't need dozens of failed attempts to get there. It succeeded almost immediately on one of its very first serious tries. That alone tells you just how carefully this telescope was engineered before it ever left Earth. The planet in that historic first image is called HIP 65426b, and this is where things start getting genuinely strange. This planet is nearly 7 times heavier than Jupiter, already a staggering amount of mass for any single world to carry. But the real problem isn't its size, it's where it's sitting. Based on everything we currently understand about how planets form, a planet this massive is supposed to form close to its star, inside a thick, swirling disk of gas and dust that provides enough raw material to build something that large. HIP 65426b is nowhere near that region. It's sitting far out in the darkness, completely alone, in a location where our current models say there simply shouldn't have been enough material to build a planet like this in the first place. So how did it get there? Scientists have started proposing theories that would have sounded like science fiction just a few years ago. Maybe this planet was violently ejected from a completely different star system during some ancient, chaotic collision and was later captured by the gravity of its current host star. Or maybe it formed alone out in the true darkness of interstellar space, wandering freely for millions of years as what astronomers call a rogue planet, until gravity finally pulled it into orbit. Some researchers have even started calling planets like this orphan giants. Worlds that essentially lost their original family of stars and were adopted by a completely different system altogether. If that explanation holds up, it means our galaxy could be quietly full of wandering giant planets drifting between star systems, occasionally getting captured into orbits that make no sense, according to everything we thought we understood about how planets are supposed to form. But HIP 65426b was only the beginning. Because once Webb kept looking, it turned its attention toward a planet that would go on to make headlines around the entire world. That planet is called K2-18b. At first, K2-18b wasn't considered anything particularly special. It was just another distant super-Earth, too large and too far away to properly study with older instruments. But once Webb finally pointed its mirror toward it, the telescope didn't just collect ordinary data. It effectively peeled back the planet's entire atmosphere, layer by layer, and what it found underneath changed everything. Webb detected water vapor almost immediately, strong and completely unmistakable. Then came methane, then carbon dioxide, and then one specific chemical that sent genuine shockwaves through observatories around the planet, dimethyl sulfide. Here on Earth, this particular chemical comes almost exclusively from living organisms in our oceans. It's not something you'd expect to find floating in the atmosphere of a lifeless world. Now, scientists have been extremely careful here, and for good reason. Dimethyl sulfide could theoretically form through non-biological chemical processes we simply haven't identified yet. Nobody is standing up and declaring that aliens have been found. But here's what makes this so genuinely compelling. Every single time researchers have tried to explain the signal away using ordinary non-biological chemistry, the explanations they've come up with keep getting more exotic, more unlikely, and frankly, more far-fetched than the simple, straightforward explanation it was supposed to replace. At some point, when every alternative theory keeps growing more complicated, while the simplest explanation keeps stubbornly pointing toward biology, Scientists have to start taking that simplest explanation seriously, even while publicly maintaining the caution that a claim this enormous absolutely deserves. Picture it for a moment. A world wrapped in a dense envelope of hydrogen, with an ocean underneath deep enough to swallow entire mountain ranges whole. Sunlight filtering weakly through a thick surrounding atmosphere, gently warming the narrow zone between permanent day and permanent night into something that could theoretically stay stable enough to support life. If life exists. Anywhere else that we've found so far, K2 18b may genuinely be our very first real contender. Now here's where the story takes a much sadder turn. Because right next door, in cosmic terms, sits a planet that should have been our easiest win, and instead became one of Webb's most frustrating discoveries. Proxima b orbits Proxima Centauri, the closest star to our own sun, sitting just over 4 light-years away. From the moment it was discovered, astronomers immediately started imagining oceans, atmospheres, maybe even the faint outlines of continents hidden beneath alien clouds. It represented everything scientists had hoped to eventually find close to home. Rocky, nearby, sitting comfortably in the temperature range needed for liquid water to exist. But when Webb finally turned its powerful gaze toward Proxima b, the excitement quickly turned into genuine disappointment. The planet orbits so close to its host star that it essentially disappears into the surrounding glare. Webb simply cannot separate the planet's faint reflected light from the far more violent radiation constantly pouring out of its parent star. We can detect the planet exists. We can measure its orbit and its gravitational pull, but we genuinely cannot see what's actually happening on its surface. And there's an even deeper problem sitting underneath that one. Proxima Centauri isn't a calm, stable star. It's a red dwarf that's particularly prone to massive solar flares, sudden, violent bursts of radiation intense enough to strip an entire planet's atmosphere away in what amounts to a geological blink of an eye. If Proxima b once had oceans, or any kind of breathable atmosphere at all, that atmosphere may have already been blasted away a very long time ago. Or the planet could be permanently locked facing its star, with one side scorched under endless daylight, while the other freezes in permanent darkness, clinging to any real chance of habitability only within a thin, narrow strip caught between perpetual day and perpetual night. This is exactly what makes Proxima b so haunting. It's the closest world to us, the one place humanity has openly dreamed about visiting one day, and yet it may remain permanently just out of reach of real understanding, at least until entirely new instrument technology gets built specifically to cut through that overwhelming stellar glare. While all of this was unfolding, Webb also turned its attention toward a very different kind of planet entirely, a scorching hot gas giant called WASP-39b. Scientists expected the usual predictable profile here. A massive planet sitting close to its star, its atmosphere boiling away in the heat. Instead, Webb uncovered one of the single most chemically complex atmospheres ever properly recorded on any planet. Water vapor, sodium, potassium, carbon monoxide, methane, and sulfur dioxide, a molecule that only forms through chemical reactions triggered by intense stellar radiation, something that had previously only ever existed in theory. No telescope had ever actually witnessed this kind of chemistry happening in real time on another world before. What made this discovery so significant wasn't just the individual chemicals themselves, but what they represented together. Webb had essentially captured the very first solid evidence of active photochemistry occurring inside an alien atmosphere. Chemical processes almost identical to the ones responsible for shaping Earth's own protective ozone layer, except playing out on a planet considerably hotter than a working furnace. It proved that even the most extreme, hostile worlds imaginable can still host genuinely complex, actively evolving atmospheres, and that the underlying chemistry of the cosmos is far richer and far more unpredictable than anyone had previously assumed. Then there was TRAPPIST-1, a system that for years was considered the single crown jewel of exoplanet discoveries. 7 Earth-sized worlds, several sitting comfortably inside the habitable zone. It represented the closest thing scientists had found to a miniature version of our own solar system, and plenty of researchers genuinely believed at least one of its planets would eventually reveal signs of life once Webb got the chance to study them properly. But once Webb analyzed the first 2 planets in that system, the results were devastating. No atmosphere at all, not a thin wispy layer, not even a faint trace. Just bare, exposed. Rock constantly bombarded by radiation from their host star. Without any surrounding atmosphere, these planets simply can't retain heat, can't shield themselves from radiation, and can't sustain the basic chemistry required to support life in any meaningful way. A system once treated as a genuine galactic oasis instead revealed itself to be little more than a chain of sterile, lifeless worlds. And yet, even this disappointment became one of Webb's most important lessons. Genuine habitability turns out to be far rarer than anyone originally imagined. And even a system that looks perfect from a distance can hide a considerably harsher reality once you actually look closely. There's something worth pausing on here because it changes how scientists are now planning future missions entirely. For years, the strategy was simple. Find a rocky planet, sitting inside a star's habitable zone, and treat it as a strong candidate for life. TRAPPIST-1 broke that assumption completely. Distance from a star isn't enough on its own. The type of star matters just as much, maybe even more. Ultra-cool dwarf stars, like the one at the center of TRAPPIST-1, tend to flare violently and unpredictably, especially in their early years. And that kind of radiation can strip a planet bare long before life ever gets a real chance to take hold. So now, researchers are shifting their search efforts toward calmer, more stable stars, even if that means looking at planets that don't fit the traditional definition of a perfect habitable zone world quite as neatly. It's a humbling shift, honestly. It means some of the planets that once excited scientists the most are now considered far less promising, while some quieter, less flashy discoveries are suddenly climbing up the priority list instead. Science doesn't move forward by being right the first time. It moves forward by being wrong in interesting, informative ways, and then adjusting the search based on what those mistakes actually teach us. Now, let's step back for a second and think about the sheer scale of what Webb is actually doing here, because it's easy to lose sight of just how extraordinary this really is. Webb isn't orbiting Earth the way older telescopes did. It sits nearly 1 million miles away, at a gravitationally stable point in space, constantly staring out into the darkness with a mirror over 6 meters wide, built from 18 individual gold-coated segments that had to unfold perfectly in space after launch, with essentially zero room for error. If even one of those segments had failed to deploy correctly, none of these discoveries would exist. Every single planet we've talked about tonight exists in our knowledge only because that unfolding sequence worked exactly as engineers hoped it would. And once it's collecting light, Webb isn't just taking a pretty picture, it's breaking that light apart into a spectrum, essentially a chemical barcode, and reading which wavelengths are missing because they were absorbed by specific molecules in a planet's atmosphere on the way to us. That's how scientists know there's water vapor on one planet, or dimethyl sulfide on another, without ever physically visiting either one. It's chemistry, conducted at a distance of trillions of kilometers, using nothing but light that's been traveling toward us for years, before it even reaches Webb's mirror. So where does all of this leave us? As Webb kept surveying star system after star system, one uncomfortable truth became impossible to ignore. The galaxy is absolutely overflowing with planets. Big ones, small ones, frozen ones, scorched ones. And yet, despite all of that sheer abundance, not one of them has revealed a clear, undeniable sign of actual biological life. We keep finding atmospheres, oceans, complex chemistry that closely resembles early Earth, but still no confirmed signal of life itself, anywhere. Scientists have started calling this the Great Silence. Every single ingredient life supposedly requires keeps showing up scattered across the galaxy in genuinely staggering abundance: water, organic molecules, stable temperature zones, rocky surfaces, and yet the actual spark of biology itself remains stubbornly absent from every world we've managed to study closely enough so far. It raises an uncomfortable question that researchers are only now beginning to seriously grapple with. Maybe the leap from simple chemistry to genuine self-sustaining life is a far rarer, far more improbable event than anyone previously assumed, even when every other necessary condition seems to line up perfectly. Or maybe, just maybe, the silence we're hearing says more about the limits of our current technology than it says about whether life actually exists out there at all. Think about what Webb has actually given us here. For the very first time in all of human history, we're no longer simply imagining these distant worlds from a comfortable distance. We're actually seeing them directly, reading their atmospheres, molecule by molecule, the same way a chemist might analyze a sample sitting on a laboratory bench. Except that sample happens to be sitting trillions of kilometers away, orbiting a star most of us will never visit in person. Every single photon Webb captures from one of these worlds has traveled an almost unimaginable distance across empty space, carrying within it a precise chemical fingerprint of exactly what that planet's atmosphere is made of. And we're not speculating anymore based on rough guesswork. We're reading the answer directly. And that brings us to the single oldest question humanity has ever asked of the universe. Are we truly alone out here? Based on everything Webb has shown us so far? The oceans hidden beneath hydrogen skies, the giant worlds drifting where physics says they shouldn't exist, the eerie silence surrounding an entire galaxy full of promising planets. The honest answer might be quietly waiting for us just beyond the very next star we decide to look at. There's something worth sitting with here before we close things out tonight. Every planet we've talked about, HIP 6542b, K2, 18b, Proxima b, WASP 39b, the 7 worlds of TRAPPIST-1, none of them were even remotely detectable to human beings until just a few decades ago. For almost the entire span of human history, everyone who ever lived looked up at the night sky and saw nothing but points of light, with no way of knowing whether a single one of them had planets at all, let alone planets with oceans, atmospheres, or the faint chemical whispers of biology. We are living through the first generation of humans who get to actually ask these questions with real data instead of pure imagination, and that's not a small thing. It's arguably one of the most significant shifts in how our species understands its own place in the universe since we first figured out the Earth wasn't the center of everything. And Webb isn't finished. It's not even close to finished. Mission planners expect this telescope to keep operating for years to come, and every single one of those years means more targets, more atmospheres, more chemical fingerprints pulled out of starlight that's been traveling toward us since long before any of us were born. Somewhere out there, sitting in Webb's future observation schedule, might be the exact planet that finally settles the question we've been circling around all night. We genuinely don't know which one it will be yet. That's what makes this moment in science so strange and so exciting at the same time. The answer might already be scheduled for next month, or it might take another decade. Nobody knows for certain. And that uncertainty is exactly why this story is worth following closely. What Webb has already shown us is genuinely only the beginning of a much bigger story. The next image, the next detailed spectrum, the next completely unexpected signal, any single one of them could reshape our entire understanding of the universe almost overnight. If you want to be here the moment that happens, make sure you're subscribed to this channel right now with notifications turned on so you never miss the discovery that finally answers the question humanity has been asking since we first looked up at the night sky.